Can you hear me?
Yeah.
Okay. Okay, we will be starting our lesson on boolean logic and boolean and logic and programming. So, this is a pretty vast overview of boolean logic. So, what we're going to be doing is I'm going to pick out some of this stuff and we're going to go into detail about it. Some of this is important, some of this you really don't need to know. Why don't we start? So, Boolean logic. So, in order for us to perform Boolean calculations, there must be some sort of data type based off of Boolean. So, there is a Boolean data type, and in Python, the two values that a Boolean variable can hold are, well, true and false. The two data types in Boolean logic. And so grasping the idea of a Boolean data type is pretty simple because it's either yes or no. There's not even a maybe. There's only two data types. It's black and white, 1 and 0. And so when we talk about comparing two things, in something known as like an if statement. An if is something that you will become very familiar with as you progress in the programming world. It is used to compare practically everything. It's very versatile. It can compare not only Boolean data types, but it will compare like integer data types, string data types. It can compare anything as long as, well, the two objects are comparable. Like, you can't compare an integer to a string. And so here are the basic logical expressions you can make or comparisons. So you can have equal equals. So if x and y are equal, then it will return true. Otherwise, it will return false. This is the exact opposite. This is x is less than y, x is less than or equal to y, greater than y, and x is greater than or equal to y. So we're just talking about like simple inequalities, like simple equations essentially. There's nothing much else to it, but that's kind of like the very, very basics of Boolean logic. Now, on top of these basic levels, we can also combine two expressions together. So if we were to say we want if x is equal to y and y is not equal to z, then instead of having to write a nested if or an if inside of an if, then we could write something known as. So this is where Boolean logic can get a tad bit confusing. With the introduction of a combination of expressions, this means that there is a much more vast number of combinations that we can make using these different types of combining expressions and the basic comparisons. So the so the normal ones are going to be equal, less, and greater than. Not is kind of a weird one. So here are three kind of combining expressions. So we have and over here, and so this is two ands, and then we have or over here, and so this is represented by two perpendicular lines, or parallel, sorry. So the way you can get this character is, I don't know if it's the same on everyone. Underneath the backspace bar, there should be a slash going from the top left corner to the bottom right corner. Now if you hold shift down on that key, so this is the normal key, and if you hold, then you should get this character. And that is the character that you will use in order to use OR. So what do these two do? Well, for AND, this means that both expression 1 and expression 2 have to turn true, not true or false. Now, for OR, it can do either expression 1 is true or expression 2 is true. And finally is not unique in that it will basically flip the value of the expression. So if expression 1 normally returns false, then it will return true. So now with the basic knowledge of this, we can now turn to logic gates. And so these logic gates are kind of like the of logics of the different Boolean algebra, except combined together, and they form a purpose that is commonly used, so people write them down so it's easier to repeat.
So there are seven basic logic gates. I'm going to talk about and, or, XOR, and not. So and was like what Matthew said earlier, where you have to have two things to be true for the output to be true. If you only have one thing that is true, then the output will be false. So you can see in the picture below, the AND gate is two lines combined into one. So this thing, that picture, the table is called a Boolean logic table, and it can basically show you which things will give you output, which things will give you, which thing will give you true and which thing will give you false. So the ones are true, and then I don't know why, but they're blanks here, but the blanks are supposed to be zeros, which are false. So next is the OR gate. The OR gate is you only need one thing of the two outputs to be true. So if one is true, then the output is true. But if none are true, then the output is false. The same thing with if you have two inputs that are true, then the output is also true. Exclusive OR is like the same as OR, but only the inputs that give the outputs that give OR, like the inputs that have one true thing are true for outputs. Like for example, if you have two true inputs, you won't get a true output, you get a false output. Okay. So a NOT gate is basically, it flips around what you put in. So if you put in a true input, then you get a false output. If you put a false input, you get a true output.
A NAND gate is like an AND gate, but like negative. So basically, if both of the values are 1, then it's going to return false, or like if both of the values are true. And as you can see in the table, the only output that's negative is when both inputs are positive or true. The NOR gate is in basically like an OR gate, and if both of the values are false, then it will return true. The XNOR, or the exclusive NOR gate, means that if both of the values are like the same, so in the first row you see that both of the values are false, so it returns true. In the last row, both of the inputs are the same and are true, so it returns.
So typically these logic gates are used when talking about like the computers all that. Now, the reason why I bring up these logic gates is to kind of show you what these different Boolean kind of calculations or expressions are capable of. And so now that we can see that like there's already 7 different kind of basic things that that we can see over here right here. These are like the 7 very basic calculations or expressions you will make. You will most likely, if you pursue programming, you will use these logic gates over and over and over again. You may know, like, consciously that you're using this logic gate, but these are kind of very common when you're programming. And on top of this is the fact that there's something known as a truth table. So a truth table is used to see the output of a logic gate. And so why is a truth table useful? Well, a truth table is categorized kind of under something known as debugging. So debugging is a huge part of programming. And so I'll get to it over here. So, wait. Okay. So, this over here is essentially a um an article written to solve JavaScript logic errors. However, this really applies, their major steps apply to all programming languages. So, we're going to look at their steps. I think there's 12 of them. Every single one of your steps is, it's very important to remember to do each one of these. Especially when you go into larger bits of code, it is very important to go through all these steps, because if you miss one, then I guarantee you will be very confused when you're trying to fix your program. So the first step is to know what you're trying to accomplish. So when you write a program that requires multiple steps, what you will want to do is you will want to kind of write down like a flow chart. And so a flow chart will essentially allow you to put in kind of prepared numbers or values to enter into, say, a method or something, and you should know exactly what you want the output to be. And then after you know what you want to do, then you need to understand what exactly happened to your code. So when you try and understand what happens to your code, you can't assume that a large part will complete what you want it to do just because you think you wrote it like that. You're going to need to go through line by line and make sure that your logic is all, it follows with what you're trying to do. You may think you're programming something, but in reality you're programming something, even if it's just slightly different. And then next is form a hypothesis. So this is kind of similar to like a scientific method, in that you need to form a hypothesis, or seeing what you think is like the buggy part of your code, or the part of the code that does not work. And many times it's pretty easy to identify, because like it's the most complicated part of the programming, or it's something you're not quite strong at. And so forming a hypothesis gives you a place to start. And when you have a place to start, it's very easy to expand off of that and find your error. The next couple of steps is something that the Python compiler will catch for you. So first off is syntax errors. So that would be like if you're programming and you forget when defining a variable. And so this will give you a syntax error, because the debugger, even though it's a computer, it can't read something that where the syntax does not make sense. It's like making a grammar mistake in your essay, like quite a severe grammar mistake, so that people can't understand what you're trying to say. So next is starting to the debugger. So the debugger is kind of like a compiler. You're not gonna find one in Python, I don't think. Next is identify your key variables or conditions. So typically when you write a program, you're going to have a couple of values that are going to get changed over and over and over again. Whether that's through like a looping or something known as recursion, which we might talk about later on. But essentially, this value will be changed multiple times, and your entire program is based off of this value. So by identifying which one is your key value, you need to make sure and track it through every single step in order to make sure that it goes through the right values. Next is identifying the suspicious code. So the suspicious code, it's kind of similar to your hypothesis that you formed up here, in that it's something where you think the code has gone wrong. Typically, the suspicious code contains a manipulation or a change of the key variable, either like getting the key variable value or changing the key variable value in some way. And so next, now that we've identified the suspicious, we can look at relevant variables. So this can be instance variables or variables that are redefined every iterates, or every single time a loop goes through a certain piece of the program, and we'll do this multiple times. Or it can be local variables, local to the method, or class variables, or variables that belong to the entire object. Now, some of these terms are very foreign to you. Identify the variables that are going to be affected in this piece of code. Next is predict what the suspicious lines should do. So this goes all the way back to step number 1, where you should know exactly what you want your code to do, and step number 2, seeing what your code is actually doing. So you should know what you want that suspicious line to do, and so if you were to just take that suspicious line out and run it in a separate program and give it the correct input value, then it should give you an output value that you should expect. And if it doesn't, then that means that you found where the bug is. And so that's where step number 10 is. It's comparing your expectations. And so finally is number 11. So 11 is one of the more complicated ones. So this is where I personally think getting it very effective. So making a table and putting out your values can help you expose logic errors, because typically your values won't randomly be off. They'll be off and they'll show a pattern of some sort, whether it's like a constant value off or it's like exponentially off or something. And so this can help you identify where the mistake is. And so logic is the best way to find a logic error is to backtrack. So from the very end, going backwards through each step can help you identify the problem. And so finally is fixing it. So after you fix it, you're gonna have to repeat this entire process all over again. You don't get the output you need. And so typically after you fix it, you're not gonna want to test just one case. You're probably gonna want to test maybe like 10 times the number of cases you were originally trying to test, because you just fixed an error, and this error could bring up more errors in case you didn't fix it correctly. And so now that we've talked about how debugging your program will work, so that kind of shows us how we can kind of apply our knowledge of like logic gates and truth tables to really helping us during programming. And so we've talked about how there's this boolean algebra stuff, like the input gates. So this is kind of like a more complicated this truth table over here is a little bit more standard as well. So you can see that as we explained before, in the place of a false there's a 0, and in the place of a true there's a 1. And so you can see through all these tables there's these combinations of 0 and 1s. So I'm not going to go through each one of these, but we can kind of scroll through them.
to actually write like this the code in Python, like these logic gates. Um, so the first one is and like for and it would be like if some like if some variable equals this number and if some other variable equals another number, then return this. So in this example, there's like x equals 2 and x equals 3. So if x did equal 2 and x did equal 3, then it would return something. And the way to write that would be just like put the first part of what you want to say in the beginning, then separated by the word and put the second part.
We can kind of see how the programming actually works. So this is printing x is equal to if x is equal to 2, and really write the word and or as this website was saying, like the and or. But Python is very unique in that as a language, it is very easy to read because instead of using characters, you can use words instead. So it's kind of very similar to just kind of like reading and writing sentences. So it's very fluid, and that's why it's so easy for beginners to learn. And so here is the in operator. There's no logic gate for that, unfortunately. So essentially what this in operator is if the variable over here, so if name is found in this thing called a list, and so a list, we'll get into that next week probably, but a list is essentially just multiple of any data type. It can be, in this case, as a string. It can be an integer. It can be a character. So this in operator can help you identify whether or not this variable, our name John, is found in this array or list. And so here is another example. Okay, and here we can find the is operator. This is kind of like the equal operator, except it does not consider the variable, but the variable itself. So even though x and y have the same value, x, y. Now if you made x is equal to y, then x is y. And finally we can see the not operator and essentially just put a not in front of it. And here's the exercise, so I will put the link inside the chat so you guys can look at it for yourselves. So this is kind of a summary of everything that we learned today. So just to cap it all off, essentially what we learned today was the basics of Boolean logic and how we can apply truth tables into debugging our own programs, as well as learning how if statements work and Boolean works in Python. So if you have any questions, you can ask it right now. Okay, well, it doesn't look like anyone has any questions, so I guess that's it for today. Thank you all for watching.